Welcome to the channel RIK Learner for JEE Mains and Advanced. A uniform cylinder of radius r equal to 3 meter is spin about its axis at an angular velocity omega o, which is equal to 40 under root pi radian per second, and placed between two perpendicular walls. The coefficient of friction between the walls and the cylinder is mu equal to 2. Then 25 k turns will the cylinder make before it stops. Find the value of k. In this question, we have to find the value of k, and here is some hint about k. Here the cylinder will make 25 turns before it comes to rest. Initially it was spinning like this. As a result, there will be friction at 2 points, one is here and one is here. At the horizontal wall, since the cylinder is spinning in counterclockwise direction, the motion is in a counterclockwise direction. As a result, the friction at this point will act in this direction. This is one of the contact force, and how much it is, that we have to think. One more is here, that is also acting in opposite direction to the motion like this. And now we have to give expressions for these two frictions. As we know, the weight of the cylinder is acting downward, and that weight is given by mg. M is mass of the cylinder. Meantime, the reaction due to the floor will act in upward direction, and I call this N1. And meantime, the cylinder is hitting this wall at this point, right? So, and that will produce a normal reaction like this. And now, since it is said that mu is the common friction between both the walls, the friction which is acting at the bottom is mu times the normal reaction which is acting perpendicular to the horizontal floor, that is N1, right? And for this one, which is vertical friction, it will be mu times into the normal reaction should be taken into consideration is N2, right? So now we have to think about the balanced forces. Since there is no horizontal motion, I can simply write N2 is equal to mu times N1. I call this equation 1, and the number of forces which are acting upside are N1 plus mu times N2, which is equals, downside is only mg. This is expression 2. Now what I do is I simply make use of equation 1 in equation 2. That means I simply substitute for N2. Okay. So what happens? It is N1 plus mu times N1 into mu, which is equals mg. Otherwise I write N1 inside bracket 1 plus mu is equals mg. It is mu square, right? So N1 is equal to mg divided by 1 plus mu square. So this is equation 3 for N1, and I use this in equation 1. I get N2, right? So now what I do, N2 is equal to mu times N1 is mg divided by 1 plus mu square. What it happens? It is simply N2 is equals mu times mg divided by 1 plus mu square. This is equation 4. One more thing, I can make it simple. That is, I can simply make some calculations here for N1. It is given that G is, say we assume it is 10. This one is 10. Okay. And this mu is 2. What it happens? So N1 will be is equals, it is 10 times m divided by, it is 2 square is 4. 4 plus 1 is 5. This is simply 2m. And for N2, I can simply do the same. This is 2 is mu into that m as it is into 10, right, divided by 1 plus 4 square. I mean 2 square, it is 5. It is, this becomes 2. So this is 4m, right? So n1 is 2m and n2 is 4m units. So we got something hints for n1 and n2. Now torque which are acting, okay? So counter torque which are acting, torque which are acting on this cylinder is how it can be used. See here, this is the vertical force, which is what actually we written mu times n2, yeah, mu times n2, and here is mu times n1, right? Here will be the center of mass of the cylinder. Okay, the counter torque which is trying to stop this wheel, this is the cylinder, not the wheel. Okay, so how much force that is, that means the torque which is acting, that can be evaluated. This is n2, right? One is mu times n2 into r is a radius of the cylinder, right? So the definition of the torque is force multiplied by perpendicular distance from the point of action. Okay, so plus mu times n1, which is here, multiplied by r, which is equals torque. It is rotating torque. So how we can write? I can simply write I alpha. Here I is the moment of inertia of the cylinder about this axis. So that will be half m r square. So further what I can write? It is the common thing are mu r, and inside I can simply write n1 plus n2, which is equals half m r square alpha. I hope I can simply cancel the terms 1 r, and when I use the 2 here, this will be 2 times this mu is 2 itself, and inside bracket n1 is what? N1 is 2m and n2 is 4m. So if I add those two, it will be 6m, right? So that is equals, this is m times r into alpha, right? I also know that r, the value of r is at 3 meter. I can make use of that number. So here I simply multiply it by 3 into alpha, right? So now you simply think this is these two things will go, and this is simply 2. So what I got? I got simply, it is 2 into 2 into 2. It is, right, 2 into 2 into 2. That is alpha, right? So I got these things. So alpha is equals 8. So now what I do is, so many radian per square second, this is alpha, but it is negative because it is retarding acceleration, right? So now I simply make use of one equation, that is omega square is equals to omega o square plus 2 alpha and theta, right? So the cylinder stops, that means final angular velocity will be 0, and this is the initial value of angular velocity, which is at here, 40 under root pi radian per second. When I make it square, so this will be 1600 pi, right, plus 2 into, and this is minus 8. Why I am using minus? It is negative, this is retardation. Okay, so and theta, what I can do now, I can simply say it is 16 theta, which is equals 1600 pi. So which implies theta is equals 100 pi, right? So this is in so many radians. So now how to convert this into number of turns, number of revolutions? I know what it is, 2 pi radians, right? 2 pi radians, which is equal to 1 revolution, right? So then 100 pi radians equal to n revolutions. Therefore what I can do, I can simply divide this 100 pi divided by 2 pi. So this will be simply 50, right? So this much 50, n is 50, but it is said before coming to rest, the cylinder will make 25k number of turns, right? So that means what we got here, the value n, which is nothing but number of turns before coming to rest. So means what I can make use, this itself is 25k. Therefore, k is equals 50 divided by 25. Definitely k is 2. The value of k what we got is 2. The answer for this question can be written in the given box. So the answer is 2. This is the value of k.